The 10th question says there are many parallel lines. This is parallel to this is parallel to this, and this is parallel to this has been given herein. And now we are required to prove that QXR, where is that? This triangle is equal to this triangle area wise. That is the proof we are required to arrive at. For that, we can the simple proof lies herein that we identify the two parallelograms and the two triangles for which we have to take out the theorem proof. You can see these two parallel and these two parallel, which means this is a parallelogram. QPTX will be the parallelogram 1, and the other parallelogram being QPYS, because this is one pair of parallel lines and the other pair is this. If two pairs of parallel lines exist, it is obviously a parallelogram. So we have two parallelograms on hand, and we can also see that both these parallelograms rest on the same base and lie between the two parallel lines. Therefore their areas are equal. The first thing, and before that we can see that this triangle QXR and this parallelogram lie between the same parallel lines QX and PT extended to R, and also they share a common base QX. Therefore the area of this triangle is half of this parallelogram, and similarly there is the other set of parallelogram and the triangle lying between same parallel lines and sharing the same base PY. Therefore this area of this triangle will be half of this parallelogram area. Now we already know that these two parallelograms QPSY and QXPT are area wise congruent, and congruent in every way of course, and therefore now putting it on paper, we have the first triangle and the first parallelogram, the second parallelogram triangle and the second parallelogram, and we know these two are congruent, and therefore as an extension I can write that these two parallelograms are equal. Therefore we can safely conclude things which are equal to the same thing are equal to one another, says Euclid's axiom number 1. Therefore we can safely conclude that these two triangles are equal area wise.